Alright, so we're going to be discussing the first law of thermodynamics, part 1. And today we're going to be expressing what does it mean. Basically, it's defined as energy is constant in the universe, therefore it cannot be destroyed or created, only transferred or converted from one type of energy to another type of energy. And in a closed system, as you can see in the upper left, the closed system can have energy input into it as well as energy released out of it. And so this can be in the form of heat or work. So the energy of the system is equivalent to the amount of heat that the closed system is absorbing, subtract the work that the system does on the surrounding. And so note that energy of the system is proportional to the temperature. So in the first case, if you put a fire underneath a closed system, the air molecules inside start to have energy transferred into it, and so we'll see more jiggling, the atoms will bounce around more, there's more kinetic energy, therefore there's more temperature increase. And note that in this case, this is a positive Q. So in this case, the change of energy is a positive Q. And then note, if we let it cool down, then what happens is the molecules start to chill out, and we have a negative Q where the energy that was in there is now transferred out of the system and into the surrounding. So that's the change of the system there. In another situation, we can imagine where we have a piston in its neutral state, right here. And on the left-hand side, what we're doing is we had put in another flame underneath, and we're adding energy to the system. And the air molecules are going to expand and then add pressure against the piston, and the piston is going to be pushed up. And so notice that the top lid of the piston has an increase in potential energy. Where does this energy come from? If energy cannot be created or destroyed, it comes from the heat, from the flame. And note in this case that the work being done, which work is force over a certain distance, is going to be measured by the pressure times the change in volume. And we can denote this as change of energy of the system is equal to, in this case, we're going to say it is, negative W, right? So work here is positive. So if you input a positive number into the equation, it's still going to be negative because of the sign. And so we get a negative W, right? So a change of system. And in the other case, let's say we don't have a flame, and what we're doing is simply putting a weight on top of the piston lid. It's going to push down and compress the air. Air is going to be now more compact. It's going to bounce around more. There's more kinetic energy. And therefore, we expect the temperature to increase. And we can denote this as positive W, right? So the work is done on the system, so that's a negative sign, and you input the negative sign into the equation and you get a positive W. So that is the law of thermodynamics in a nutshell. In the next video, we'll be talking about the different type of processes that involve this law.